Hi friends, so we are into our course on risk conscious operation management of complex engineering system, and this is fourth week or fourth module, that is risk conscious culture. As I mentioned, risk conscious culture is having a very soft notion in the context of complete risk conscious operation management. But at the same time, it is also a sort of a gap area that has been discovered during accidents, that if we have some design intent, how far they will be able to meet, it depends on human and organization, and then how far you will be able to meet the technical elements. It's working up to its highest level of safety or minimization of risk, and that is where we will be discussing now in this lecture, that is fifth lecture or last lecture of RCC, that is risk conscious culture, and this is on technical element. I would say technical safety elements actually, because we are in the realm of safety only. So I am Professor Prabhakar V. Vardhe, and this will be our fifth lecture on risk conscious culture, and technical element will be the focus of this lecture. Okay, now let us understand the background or introduction of risk conscious culture and how it relates to, rather it should relate to risk conscious culture, because every technical element we will be seeing what are those technical elements. It has been built into the system, but how effectively it will meet its desired or acceptable level of acceptable level of goals, it depends on how consciously people are working on those areas. So let us see, first heading is requirements of operation in this era. Need of more structured and measurable ecosystems. Just to remove ambiguity about the linguistic variable, let us be like science is all about measurable. So why this approach should not go to measurable level or measurable system? So that's how, and it should be structured. What we mean by structure is it can be understood, interpreted and reviewed at any level by anybody, whether it is a plant operation staff or it is a regulator or even a member of public domain. So it should be a structured approach. We should be able to deductively or inductively analyze what happened, why happened, what was the root cause, right, when we are looking at the framework itself, or the chronological order of the event that are happening, and they are measurable event. Okay, like risk is now measurable parameter. Okay, so now characterization of organizational and reference / average individual conscious level. Unless until we have a reference, we cannot talk about whether there is a deterioration or whether it is improvement. So it is quite possible that at operational level itself, the simulator studies are performed to see what is the training level or qualification level, and what kind of hardware, that is technical element that we have built, and whether the humans are geared up to achieve the safety goals. Okay, risk consciousness is now is a part of technical framework. So it is a inherent part of that. It is there, but then here we are trying to improve upon it. So we are talking about it actually. Okay, a technical framework is based on major tasks. Next slide you will see which are the major tasks. Higher level task categorization. Okay, whether it is a design, operation, or aging management or anything. Integrated framework. The framework is all elements are trying to tell the status in a integrated manner. regular RCC monitoring through general and specific. I mean, a quality checklist is required to be developed. How these elements are being monitored. Okay, this is just an observation that how a common definition of a culture may not be adequate for risk conscious culture or safety culture because this definition can be argued to be a narrow definition and culture can be defined by making consciousness as the fundamental to encompass one or more holistic definition of culture. And that is the reason in this course or in this lecture we have been defining various whether it is policy, whether it is operation ecosystem, everywhere we are trying to develop our own definition because it requires a different treatment. Therefore, the purpose of risk conscious culture is defined as what is consciousness to an individual, is culture to an organization, is a collective sense. This is IAS this thing on this, and we have for risk based engineering we have developed our own definition. But what I am saying, there is no one common factor that satisfy everything on the horizon. So okay, what we have is the risk conscious culture, how we are trying to achieve when we start from the bottom, but let us have a look at these are various activities. So you can say these are various technical element. Okay. These are various major categories we have: design, operation, maintenance, safety and regulation. Now we are having a complete another level of technical activity which supports our IRB, integrated risk based engineering. Okay. And how, so what we see first is quality attributes. Whatever job we do, now these attributes are available at national and international level. So whatever, like I am doing risk and reliability modeling and there are indicators. Okay. So this will tell me how well I have done. Like for example, if in my study, if I am using some data and the total percentage of plant specific data is only 10%, that reflects on my quality of an operating plant data, and efforts have to be made. And I think one of the slides I have to, given the ways how this can be compensated. But again the goal remains that to satisfy the quality attribute, goal remains that we have to have a quality data. Now risk and reliability indicator, after data we got risk and reliability indicators we have got. So now this will be one element which will be input to our this qualitative means deterministic safety assessment, and quantitative means probabilistic risk assessment. And these are entering like input from root cause analysis. If the events have happened in the plant in last 1 year, whether I have done root cause analysis for all the failures, or I have not done for any event, or I have done for all the events. But of course, for it is not possible to do root cause analysis for all the events. So what we have a for root cause analysis we have a risk matrix. So in risk matrix we can demonstrate that out of n number of failure, only 2 failures needed attention from root cause analysis. And root cause analysis per se, I will make it a point, it should not remain limited to brainstorming only, because if we have conceived that root cause analysis can be performed at 3 levels. Level 1, it can be done in 15 days time, wherein you collect the data from the site where the failure has happened, try to have a chronological chart and try to understand what all has happened. If this particular event is not very serious event, then we can do a level 1. Level 2 where we will do when there is a confusion what are the safety implication of this event, but definitely it was not a routine event. So we go for level 2, it might take 1 or 2 months. But level 3 means it has to go into all sorts of analysis, and it might take 6 months to one year. So that should be the seriousness when we do root cause analysis. It should not limit itself to the brainstorming session, like meeting like session where 4 experts they meet, because the reason is, if this set of people are meeting and giving some judgment, if I have a second set of people, they might give a different judgment. So it should be scientifically based. It should be based on, inference should be based on very good findings, evidence, and those evidence have been brought to the scientific level for level 3 risk or root cause analysis. Then we also review the regulatory compliances. So this is something, these activities in plant, it happens annually actually, or maybe twice, but it could be biannual or annual activity. So what are the finding here? This tells me a lot about my risk conscious culture. If any major point is left out, or even if it is a point which was not major or minor, but it did not find any attention, and then what root cause we understood from there. And root causes are generic, like simple one root cause could be that some failure occurred and the replaced component was not meeting all the specifications. So that means the maintenance did not check the quality attribute required, or specification for the component. Point number 1. Point number 2, some decisions which are taken on an ad hoc basis, because for every change or modification you require huge resources. So some ad hoc decision was taken, okay, let us manage with this, operate the plant, but then it became sort of a permanent. So it is not a good culture. If anything was to be done, it has to be done, and we don't require regulator to point out what was that, because regulators have a limitation on oversight. They cannot monitor each and every activity. So this is what. And then hazard management. Hazard management is one of the, because it directly forms input to the risk analysis. Okay. So when we do the performance review, all this input they come into it, and then we have therein we have one deterministic component, qualitative, quantitative component, and then we have assessment of integrated risk insights into the plant. And then whatever insights are there, whether it was related to design, it was related to operation, maintenance, services, regulation, it will go. Of course, this whole thing will go to regulator, and regulator themselves will see from there. But then before that, if you can point out, okay, this was the thing, compliance or anything issues and all. So, okay, now all these things, they support the smooth functioning of the technical element of risk conscious culture, and they are giving input how what is the level of risk conscious culture in the plant. Let us say risk engineering modification. Plant modification is a not regular, but it is an activity which keeps happening actually. Okay, and as soon as some new findings are there, plant modifications are enacted. So how many modifications are done? This will tell the positive side of it. What was the reason and how we have done it. So it is a positive side of it, that plant is being modified, and it is contributing to the risk reduction or safety improvement. Then reactor physics, and it depends on, reactor physics is basically related to nuclear, but in many process systems they will have their own requirement. Chemistry services normally form all the process plant, what kind of degradation, corrosion or any deficiency has been noted, thinning up. So these activities are very important, because it tells into aging of the component. Okay. So we can say risk conscious engineering modification, risk conscious parameter monitoring from the physics point of view or from chemistry point of view. This can be a simple, and these are all part of the services to ensure safety services, I would say. Now, monitoring and surveillance. If any deficiency was noted, maybe because of audio visual system which alarms control room, or with some human limitation, or so some anything is noted, that again modification or root cause analysis so this is one activity. Then so these are all the plant activities wherein this input should go, and the performance review is one that will reveal the issues or it will endorse the best practices in the plant. Then maintenance is one of the volume wise is one of the biggest area, or whether you take human resource, inventory or hours of operation, it is one of the important activity. And along with that we have this in-service inspection and condition monitoring. CM stands for condition monitoring, in-service inspection. So generally their nature of things are similar. The ISI is for structural integrity assurance, and same condition monitoring same for rotating equipments, like motor, turbines, okay, pumps, okay. So assuring that the health is being maintained. Then safety performance review. Safety performance review are the indicators that tell us how many events have happened, what is the level, whether there are consequences and all. So this becomes one of the major element from the point of view of risk conscious culture, and that has to be attended to. Training qualification from human reliability point of view, it tells, and if there is a simulator exercises, they will form part of the input. And then quality audit. Audit is basically for one is internal audit, another one is external audit. Okay, external audit means for regulator. They come, regulator come and they perform audit on the plant, well defined checklist, criteria they are there, and based on that safety status of the plant is characterized, and this forms a very big input for assigning a risk conscious culture. Regulatory communication and compliance assurance. These two tell us what is the opinion of regulators about this plant, and from there risk conscious culture, a matrix can be designed to have a risk conscious culture in the plant. Now, having said this, there are, if I have to put into broad category, all these elements they form into one organization element. Then PRA is central to this thing. So, or I will say even DSA also, okay. And then training and qualification, and then quality assurance audit, and I am writing H, root cause analysis. 2 doesn't mean anything. Root cause analysis or human root cause analysis. I think we discussed in one of the slides. So these two, as I indicated here, have been discussed in previous lecture. So we will touch upon these 4 points. Okay. So these are the technical management, the major pillars of technical management. Because so organizational mandate. Well, organizational mandates or policy or decisions or human, we have been talking about it. So that's why I kept this slide very crisp. So what is the organizational mandate? Plant management. Plant management has got a policy on risk conscious culture or safety culture, and that policy, how far it is being followed. As I give simple example which is applicable to industrial system, wearing helmet when we are on work. Okay. Then when we go to the higher level or R&D level, whether aging management program is going on and what are the findings of the plant. Okay. And then if it comes to further the digital logics that are used in the plant, because software, there is a big question. So, whether the protection logic operating on digital systems configuration, whether we have a standby or redundant independent system to take care of any uncertainty in operation of the protection logic. So, the range is very wide actually, and risk conscious culture should bring out all these issues. Major element of risk conscious policy. I think we have discussed many risk conscious policy once again we will touch upon. Then every organization should have an organization chart where the mode of communication and mode of authority, okay, all those things are indicated very clearly, okay, and they are being monitored how they are effective actually. So, one is having these are normally forming this organizational chart, they form part of safety technical specification, okay. And then if any element is missing from there, that must be added, or if any authority or in line of communication is deficient, that need to be discovered, okay. And then safety and security policy. Earlier it used to be only safety, now it is a safety and security policy. And human resource training, because we are talking about more emphasis is there on human, and human only relate to organizational element. So, human is still the factor that need to be considered. So, so you can see major element of organizational factors. What is that? Formulation and implementation of a risk conscious culture policy. So, implementation level, whether the formulation policy has been drafted, it has been approved and it has been implemented, okay. And regulatory or peer review input, as we mentioned in the last slide, these inputs are very important, because expert independent of operating organization, they are trying to point out strengths and weaknesses of the plant, and if there are weaknesses, plant, how proactive plant is to take the corrective action. I mean, in short, it should not go to the next year, it should get resolved, and if any problem is there, a justification should be drafted. Then of course, I said proactive approach to understand weakness of the plant, and collective consciousness. More than human or organizational, what is the collective consciousness of the plant? We discussed one example. One plant is having one collective consciousness, other plant is having other collective consciousness. Sometimes they are similar, sometimes one is, and then there is a organizational consciousness. So, plant and organization, how they can differ, but finally, ideally speaking, the organizational and plants, if there are more than one plant located in the same organization, then they should be reflecting same culture and collective consciousness. Evaluation trends of RCC and organizational as well as, so there has to be ongoing evaluation of this, employing a standard checklist procedure. It's a very simple and elegant procedure, even if it is a 1000-page report, like a PRA report, for each section of PRA, a checklist is attached, wherein proactively we bring out the strength and weakness of that particular exercise, and for regulator or for independent reviewer, before going into the details of that particular section or that complete report, he can see the checklist and he can pass the judgment whether a detailed review is required or not, or if review is to be done, which are the 4 or 5 points need to be addressed. So, so here we have internal review and then regulatory review. Safety performance review, in last slide we discussed, it is very important that periodically in the interest of safety or risk reduction, the performance review should be planned, and whatever insight or finding, this is an internal document, okay. So, internal document, internal exercise. So, I would say going for a safety performance review, by the operating organization is a proactive approach to understand strength and weakness of the plant, and it is a part of good safety culture actually, or risk conscious culture. Now, PRA model policy. PRA is a very resource consuming and very elaborate exercise. Just for our understanding, a PRA report can have something like 5 to 7 volumes, and it might have 2000 to 5000 pages, or it might start with 300 pages and go up to 2000 pages. I mean, depends on the complexity of the plant. So, and then when we enhance the scope from level 1 to level 2 to level 3, level 1 we know that. So, this is level 1, level 2, level 3, it is in the context of nuclear plant. But for other plants, it will be either level 1 and consequences in the public domain, that is level 3. So, level 2 doesn't come into the picture. Then PRA scope. Well, it's like, what is the scope of PRA? It is full power operation, transient operation, low power operation, shutdown. I mentioned in one of the slides that we have complete risk the plant state. And coverage should be complete if we want to talk about, or if we want to have confidence in PRA. Then regulatory acceptance criteria. For every activity, or at least at the nodal activities, we should have a probabilistic criteria. Like for the main result, we have a risk criteria of 1 into 10⁻⁶ reactor per year. Okay, if I am going away, or if I am not meeting those compliances, at least I have a target with me to meet this criteria. And if I am meeting this criteria, 1 into 10⁻⁶, again it will react to 6 sigma. In 6 sigma, 3.6 into 10⁻⁶ is like 1 sigma, 3 sigma, but you have made the sigma level. 3.6 failure in 1 million operation, and that's how we can characterize our acceptance criteria also. Quality assurance. Quality, though it appears to be a very old concept, but quality still is followed very seriously, and quality only can deliver the reliability. If I do not have a quality statement on my component, procurement, or even system, procedure, formulation, I do not have my standard in place. Okay, and for quality assurance, there are documents that are available. Whatever area you choose, you can have a quality assurance document. And then PRA application policy. This is basically in principle a decision at the regulatory level or at the plant level, but approved by a regulator. What is the position? Like at an international level, risk informed policy. It takes into account that probabilistic risk assessment should be used as far as possible, and it is justifiable for a case which is going to the regulator. So, that way these policies are there, but then at national level, how far we, but then most of the countries, they are following this philosophy. So, one can take note of it that everywhere there is a subjectivity when it goes to the application. Regulatory provision for PR application. Okay. Now, advancement in training. I can talk about n number of aids, like risk monitor should be there, then simulator sessions should be there, because the training on plant is not as robust as an option, because the plant operation should not be disrupted. So, we cannot simulate an accident, but on simulator we can simulate the accident, and the learning is very high. Of course, the simulator should be qualified, and it should be reflecting as built, as operated, as designed condition of the plant. Okay, and then nowadays AI and ML coming in a big way. So, operator advisory system, especially for emergency, these are not an option, but it is become a necessity, because the cognitive load during emergency condition is very high. Training, development of data and stress levels and all. So, it should be like self-sufficient to have your own data. I mean, that habit of depending on Western document should be reduced to the possible, because the document which are available in open domain are meant for certain ecosystem which is not applicable for us. So, we should develop our own methods and model, provision of monitoring human body, language and brain wave and all that. In fact, these experiments we have done in one of the simulator room, and we found very good finding that system can have its own capability to manage stresses, and human can have its own capacity, and when they overlap, there is a stress is going beyond and they are overlapping, then the possibility of accidents are there, the way it is applicable to structural systems. and then quality policies and all. So this we have been discussing, like, availability of resource is required, plant areas, maintenance management. Actually, maintenance management is a very complex exercise, and here reliability centered maintenance or risk based maintenance have been doing very well, because first of all, the quantum of maintenance activity comes down because we have identification, prioritization and optimization in one place, and then finally we are having more resources for focusing on the important aspect than other trivial aspects. So that also we have identified. So that, and similarly risk based technical specification, these are all various and then services. Last item is services. It is not R&D and monitoring services are inherent to the plant and all. So okay, in this lecture we have seen technical element in RCC and RCC, risk conscious culture, and then elaborate discussion on framework and major element of the technical elements in operating plant, major 6 pillars of RCC, risk conscious culture. Okay, then for this week, what are the major remarks and conclusion? Let us see. Risk conscious culture is a soft policy. I mean, unless until we have a framework designed and built to implement this culture, we may not accrue the benefit, number one. And then risk conscious culture highlight the role of culture. I mean, culture is a very trivial definition. It is you can get it, but then here it reflects on human performance, which is the major contributor to accidents. So it becomes so culture becomes very important, and improving risk conscious culture in perpetuity becomes the goal of any organization. Like societal cultures, we can learn some intimate element from the societal system, and the ultimate objective is de-risking. Okay, and then we have interfacing, like just I mentioned, technical and risk conscious culture, they are interfacing. So if their interfaces are not developed and then organizational elements are not integrated there, the chances of success are less. Okay, I'll quote one example that after one of my lecture in abroad, once the lecture was over, the department head, he turned to all his colleagues, around 50 people sitting in the hall, and then he said, the safety is the dharma. Safety is your dharma from today onwards. Our risk is a dharma, because safety has a qualitative notion. So it is very for one person what is safety, for other it could be, but when I have a numerical parameter and I have demonstrated it in the documentation, probably it becomes a robust mechanism. So then he said that it is a thing which should be followed like a dharma. Okay, so with this week 4 is over, and these are the references. Around I think 46 references are there. Since this lecture is based on my book, same references I have quoted, but probably as and when you feel like, you can refer these papers or documents or books, and probably you will be benefited. Thank you.